All right, so we are looking at exponents, variables, and coefficients. This is going to be a really brief overview of these things because we're going to spend a whole week looking at exponents and the different rules that operate when we are working with exponents. So just take a second and think about, what do you already know about exponents? So an exponent is that small number that we add at the top right of a number or a variable. So for example, we have this 4 and we say to the third power. That little 3 is the exponent. And what the exponent tells us is how many times the number is multiplied by itself. So this 4 to the third would be 4 times 4 times 4, which is 64. We have to be really careful because an exponent is a number times itself as many times as the exponent shows. It is not the number times the exponent. So 4 to the third power is not the same thing as 4 times 3. And we have to be really careful because 4 to the third power is 64 and 4 times 3 is 12. So if we get these things mixed up, we're going to end up with super different answers. So remember, if we see that little number up there, that exponent, that means we're multiplying the number by itself that many times. 4 times 4 times 4. It is not the same thing as 4 times 3. Take a second and try and figure out what these exponential expressions equal. And you can use a calculator if you need to. All right, so 2 to the fourth power is 2 times 2 times 2 times 2. So we have 2 times 2 is 4, times 2 is 8, times 2 is 16. This is 25. 5 times 5 is 25. 3 to the seventh power, that's 3 times 3 times 3 times 3 times 3 times 3 times 3 is 2,187. And then 8 to the third is 512. Now you'll notice that these later numbers, especially this 3 to the seventh power, is way bigger than you would think. And that's where we get this term exponential growth. When things grow exponentially, they get really big really fast. And so that's what happens when we're dealing with exponents. These numbers get really big really fast. The higher the exponent, the much, much larger your answer is going to be. Take just a second and think about, how would you write these expressions using exponents? All right, so here we have 3 7s. So I'm going to do 7 to the third. And here we have 1, 2, 3, 4, 5, 6, 7 9s. So I'm going to write it as 9 to the seventh. We have 2 12s. And we have 1, 2, 3, 4, 5 65s. These are the ways that we can write these expressions as exponents. Now, when we're dealing with exponents, we often have as well variables and coefficients. Take just a second and think about, what do you already know about variables and what do you already know about coefficients? And it's okay if the answer is nothing, because we're going to look at them. So variables are usually represented as a letter, like X or Y, which we'll see a lot, especially in algebra. And we usually don't know what number a variable represents, which is why we use a variable instead of a number. The value can also change from equation to equation. So for example, if I have 3 plus x equals 5, then I know that in this equation, x equals 2. But I could have another equation later that says 3 plus x equals 10. And in this equation, x equals 7. In two different equations, the same variable can equal two different things. However, if I have the same variable in the same equation, for example, if I had this guy here, instead of 3 plus x equals 5, if I had 3 plus x equals 7, x would equal 2 in both cases. So I had 3 plus 2 equals 7. It is not possible in the same equation for the same variable to equal two different things. So if I have two x's in this equation, those two x's have to equal the same thing. Whereas if I have two different equations that both happen to have x, they could equal something different. Coefficients are numbers that are written along with a variable, and the coefficient is a constant that multiplies the variable. So remember, we said if there's no operation happening or shown between two things, we're assuming multiplication in algebra. And when there's an exponent attached to a variable, the coefficient is not included within the domain of that exponent. And that might sound confusing, but once we start working with it, you'll see how it really changes things. For example, here I have 2x plus 8 equals 18. And that means 2 times x plus 8 equals 18. So in this example, x equals 5. 2 times 5 plus 8 equals 18. Pause this video and work out these examples to find the value of the variables. All right, so when we are working with variables like this, one way that we can do this, if you're not sure, is if we have something like this, g plus 16 equals 56. We want to always get the variable by itself on one side of the equal sign, and all of the numbers that we know by themselves on the other side of the equal sign. And the way we can do that is we can do anything we want in a situation like this as long as we do the same thing on both sides of the equal sign. So for example, if I have like 5 equals 5, that's true, right? 5 and 5 are the same. I can add 1 over here, but if I do that, I have to also add 1 over here. 1 plus 5 equals 5 plus 1. So I can do anything I want. I can add, I can subtract, I can multiply, I can divide, as long as I do the exact same thing on both sides of the equal sign. So in this example with g, I'm going to subtract 16. So I'm doing the opposite operation. Here it's adding, I'm subtracting. So I'm going to also subtract here so that I end up with g equals 40. Here I have h divided by 3 equals 10. And I can do the same thing here. I want the numbers to be on one side and the variable to be on the other side. And since I'm dividing, I'm going to multiply both sides by 3 so that I get h equals 30. Here, it's not as straightforward because I don't have a sign right before this 25. But remember, if I don't have a sign, it counts as a positive number. So what I'm going to do is I'm going to subtract 25 from both sides so that I end up with negative k, and I have to make sure I keep that negative because it's connected to the k, equals negative 15. And now, since they're both negative, they can cancel each other out. So really, k equals 15. Here I have 3x equals 36. 3 is multiplying that x. And since I'm multiplying, I want to divide both sides by 3 so that I get x equals 12. And then the last one, 7z equals 49. That 7 is multiplying, so I'm going to divide by 7. And so z equals 7. So when we're looking at a variable, we have these different parts. So the 4 here is a coefficient, the x is a variable, and the 2 is the exponent. So this 4 is multiplying this x, and this 2 is saying that we have the x times itself. So if we imagine that x equals 3 in this scenario, when we're solving for this, we have to use the exponent first before we multiply the coefficient. It really looks like x squared times 4. So we'd get x times x, or 3 times 3, and then times 4, which is 36. And this is really important. We have to be careful, because if we work from left to right and do 4 times 3, which is 12, squared, we end up with 144, which is not even a little bit close to 36. And this is because of the order of operations, which we will learn about next.